Well, I hope everybody did a good job drawing the different histograms and noticing the difference between bar graphs and histograms and things like that. So this is another way to actually kind of visualize the data. And so the three other things that we want to talk about in this section are stem and leaf plots, scatter plots, and time series plots. So a stem and leaf plot is somewhere between the raw data and the frequency table. So it's somewhere in the frequency table. And so what I mean is the raw data would just be the big list. So if you look at below, like this would actually be like the raw data. It's not sorted, it may not be in order, it's just a bunch of numbers thrown out and stuff like that. Where the frequency table actually goes through, categorizes them, tells you how many are in each category and things like that. So the stem and leaf is better than the raw data, but not quite as good as the frequency. So that's why we sort of say it's in the middle. It's kind of in between those two. So what it does is it illustrates the grouping of the data, but it also actually shows you all the data, which is kind of an interesting thing. So it illustrates all the data. But you can actually see all the data. So like on a frequency distribution, it illustrates it and you know they're in categories, but like all you're seeing is like there's 5 of this. You're not actually being able to kind of see each individual data point. And you'll see when we actually do a stem and leaf plot, you'll actually be able to see each and every data point that's there. And then finally, each data point gets split into the stem and the leaf in this case. So each is split into a stem and a leaf. And the leaf is always the last significant digit. So let's kind of look at this to see what's going on. So in this case, first thing to notice is all of our data is in the tens position. So it's between, what do we got, 70 something, 78, 79, up to 90 something. So it's all 2 digits. So what this means is, if we were thinking about this from like a Math 110's perspective, like the stem is going to be like the tens position, the leaves are going to be the ones position for this problem. And so in this case, we've already listed the stem. So the only tens digits possibilities that we have are 7, 8, and 9. And so now what we want to do is list all the ones positions that occur for each of these guys. And you list them as many times as they occur. So even though we might have, 3 8s on there, just because I listed it once, I still need to list it every single time. So don't not list it just because it's been on there. So again, kind of the same thing when we add all these guys up, when we add our leaves up, we better get the same number. So let's add these together first just to check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like there should be 24 numbers total when we're all said and done. So let's go ahead and list these guys out. Now, you don't have to list them in order. It definitely looks prettier if you list them in order, but in reality, you could just kind of write them all down as they come, or you could go back later and sort them. So it's kind of up to you. It's not wrong to list them, lowest to highest. It's not wrong to list them any old way. So it's probably easier to list them any old way. So I'll let you guys do whatever you want. But in this case, so 78, so that means we're going to put an 8 here for the leaf, and I scratch it out to know I'm going to get rid of it. I got a 79, so I'm going to get a 9. Notice I don't put any commas or anything like that. I just list all the numbers. So there's another 9, and then an 8. So if you wanted, after you listed them all out, you could go back and actually like reorder them lowest to highest, but I'm just going to leave mine like this for now. And so I can see that I've got 1, 2, 3, 4, 5 numbers in the 70s is the idea. So now let's list the 80s. So in this case, I've got a 1, a 6, a 0, a 2. Oops, I missed a 1. Sorry. Let's see. This is why you gotta be careful. It's so easy to make a mistake. So a 1, a 2, a 3, a 4, another 4, a 0, a 3, a 7, a 4, 0, 5, 8, and a 0. All right. And so again, if I add these up, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 leaves, which means that there were 16 numbers in the 80s. So let me put the 5 up here. And finally, let's do the 9s. So we got 92, 90, and 5. So that gives us 3. So again, we should check and make sure we add this up to 24. So 16 plus 5 is 21, plus 3 is 24. So good, it looks good. So one of the things I like about the stem and leaf plot is the cool thing is, if you kind of did this with it, it kind of looks like the histogram on its side. So if you were to turn this the other way, upside down, and make it into vertical lines, you're really looking at the histogram, in even though it's just numbers in that case, because by listing out all the digits, and if you try to space them so they're fairly even, like you end up kind of making almost a histogram with the stem and leaf plot. So again, I think that's one of the cool things about those. But all right, so I'm gonna have you guys practice the next one on your own. So in this case, since all these are going to be like, we've got 1s and 10s and then stuff after the decimal. So in this case, think of the decimal as going to be the in-between. So the stuff to the right of the decimal is going to be your leaves. Things to the left of the decimal are going to be your stems in that case. So I'll let you guys do that one on your own. And then next, what we want to do is talk about a scatter plot. So again, pause the video, practice that one, then come back and look at scatter plots. So scatter plots, think of this as like plotting lines and things like that in an algebra class. So everything that we're going to work on is going to be like ordered pairs. And what it's trying to do is it's trying to show the relationship between two quantitative variables. Or numerical variables. So later we're going to call this a correlation, which I call in the next section. So later at the end of the semester we're going to study this more. But again, that's what you would use these scatter plots for. You're trying to see if there's a correlation between the two variables. So we want to test is a correlation or kind of a relationship between the two variables. So again, that won't be till later where we do the relationship. For right now, we just want to actually focus on kind of plotting the data and stuff. So in this case, this example's already been done for us, which is kind of nice. So we've got TV prices and their size. So in this case, what we've done is we've kind of assumed that the size is going to represent our X, or our horizontal axis. The price is going to represent our Y. And so what we're really looking at are a bunch of ordered pairs. So like in this case, 43 would be the same thing as like 43 comma 500. So if I go down here on our graph, it looks like it's this guy right here. So this would be our 43 comma 500. And so what we're doing is we're just going through and figuring out each point. So the next point would be 55 comma 900. So that looks like it's going to fall right here. So this would be 55 comma 900. So you really are just going through plotting points like you would in an algebra class or something like that. So remember, when we plot points, we always go to the right first and then up. So we always go along the x and then up the y. So don't flip them around or anything like that, otherwise we'll get messed up. So I'll let you guys look at that example, and then I'm going to have you guys try this on your own. So in this case, we were talking about houses and the selling price. So the x is going to be the size of our house. The y is going to be the selling price of our house. And so in this case, it's in thousands. So that's why we're only talking about 400, 410. That's why it's, the numbers are a little bit smaller. And then we've got the square footage along the x-axis. So again, none of these numbers are perfect, just like the numbers above weren't perfect. So just do your best estimating them. I mean, it's a little tricky to plot these when we don't have bigger graphs and stuff like that. So just try your best. Again, think of these as ordered pairs. So the first one's going to be 2521 comma 400. So that means I'd go along the bottom 2521 comma 400. So I'm going to go over about this far probably, and then I'm going to go up 400, and that's going to be my first point. And then you guys just keep working through the rest of them on your own so you can actually figure out what's going on and see kind of what the graph looks like. So again, pause the video at this point, finish up that scatter plot, come back, and we'll talk one last time about time series plot, and we'll finally be done for the day. So, all right. So a time series plot, surprisingly enough, tracks the change. Oops, I got the eraser on. Tracks the changes over time. I mean, shocking, isn't it? Unbelievable. So since it's called a time series plot. So what a time series plot really is it's just a scatter plot where we've connected the dots, is the idea. So what we do is we start by making a scatter plot. And then what we do is we connect the dots, but instead of trying to make it curved and make it try to fit, what we want to do is actually connect these dots with straight lines going from point to point. So we don't want this to look like a nice curve. It's going to look jagged and things like that. So if we look at the data down below, so again, this one's already been done for us. So we're looking at Disney revenue over the years. So as you can see, if you bought Disney stock a long time ago, you could be probably a billionaire by now, since their stock's just going up and up and up and up, especially now that they've bought Star Wars and Disney Plus and who knows what all else. But anyway, so in this case, our x coordinate's going to be our years, our horizontal axis. Our y is going to be the revenue in billions of dollars. So again, if we look at our chart, we've got the years along the bottom, and we've got our revenue in billions across the vertical axis. And so if we look, 1993 was approximately 8.5, and so again, that's going to be that graph for us, 9.3 comma 8.5. And then the next year was 94, which is right here, which was about 10.4. And so notice what we're doing is we're just making sharp lines. Let me make this wider so you can see. Maybe a different color. So what we're doing is we're trying to do sharp lines for each of these different. So we're not trying to make it into a curve. Again, we want to make a bunch of sharp lines. So as you plot these points, just connect a line to each one of them. So if it looks jagged, if it goes up, it goes down, that's fine. We don't want to smooth it out. We don't want it to look like a nice smooth curve or anything like that. We want it to have that jagged nature. That's kind of the nature of a time series plot, is that it's going to be jagged. It won't necessarily be a nice smooth curve or anything like that. So there's none of those to practice or anything like that. But again, if you were to do one, you first plot all the points just like you would do a scatter plot, and then just connect each of the points with a nice straight line. So again, if you have any questions, I'll be around the computer all day tomorrow. Feel free to ask away. Otherwise, have fun making these graphs. Get out your colored pencils and all that kind of stuff. And I will see you tomorrow.